Okay, by now you should have read section 10.5, which was your homework for last night. It was a lengthy assignment, and I mentioned that on the dashboard. But we're going to concentrate on a little bit, just a small piece of that today, which is the focus directrix definition of conic sections. Now, the focus directrix definition says this: D2 is equal to ED1, where D1 is the distance from directrix, and I'll use dx to shorten it, to the conic. D2 is focus to conic, and E is eccentricity. Now, if E is between 0 and 1, you have an ellipse. If E is equal to 1, that's a parabola. And if E is greater than 1, that is a hyperbola. Okay, we're going to draw one of each on this special graph paper. And to get it started, and you should do this yourselves, you should print out the special graph paper that I posted, get out a ruler, preferably one that's transparent, which will help with this process. First of all, put a dot in the middle, because that's going to be the focus. Every time that will be the focus in using the special graph paper. All right, I want you to count out 3 concentric circles, 1, 2, 3, and perpendicular to the top and the bottom of the paper, draw a dashed line like this, and that will be the directrix for the conic. Now, these two things are exactly 3 units apart. We're going to take advantage of that when we draw especially the ellipse and the hyperbola. But for the time, we're going to start with the parabola, and I'm not going to make a table for it like we'll the other two, because it just takes up space. But since a parabola E is equal to 1, D2 and D1 are equal in length. That means that there will be a point about 1.5 units, or exactly 1.5 units, about right there, from the directrix to the focus. I'll put an X there because it's not an actual point on the conic. Now, that falls on a perpendicular through the directrix and the focus. The shortest distance between the directrix and the focus is 3 units, and halfway is 1.5. That means that's the vertex of this parabola. Now, here's the genius of the special graph paper. If I lay my ruler right there, every point on the edge of that ruler is exactly 2 units from the directrix, since they're parallel lines. If I count out 2 units, or 2 concentric circles, those 2 points satisfy the condition that D2 is equal to D1. Similarly, if I lay my ruler like that, and it's a coincidence that it's on the focus. The important point here is that this is 3 units from the directrix, every point along here. So if I come out 3 units, those 2 points satisfy the focus directrix definition for parabola. Again, move out 4, or move over to 4 units. One more concentric circle out here, and here, and this is why it's convenient to have the transparent ruler, because it's a lot easier to see where you're going with this stuff. Okay, so now I am 5 units, 1, 2, 3, 4, 5. These points are all 5 from the directrix. I come out 1 more concentric circle. That should be enough. And you can see the parabola forming. All right, we're just going to sketch it in. And there is the parabola formed by the focus directrix definition. All right. For an ellipse, the eccentricity has to be between 0 and 1. Now, I have it set up so that an eccentricity of 1/2 is the perfect amount. I'll make a table for this, D2 and D1. Now, if I put 1 and 1/2 here, D2 is equal to 81. There's no point that's going to satisfy that condition, because if I come one away here and try to go 1/2, it's not going to work. But it will work if I put 2 here and 1. So I come 2 from the directrix and 1 from the focus, and I'm going to do this in red so we can see a little bit better. That'll make a point right there. That will be one of the vertices of the ellipse. All right, let's go 3 and 3/2. Okay, again, if I lay the ruler, the straight edge, it is, because we're not using it to measure anything, we're just counting circles. All right, these points are 3 units from the directrix. Those points are 3/2, 1.5 from focus. 4 and 2. Okay. 4 and 2. And again, if this is going a little bit too fast for you, you can go back and you can stop, okay? And you can do this a little bit more slowly. I'm trying to save memory space. 5 and 5/2. 6 and 3 are going to be the other ones. Okay, so I move this over here. Now my straight edge, this is 5 units from the directrix. Well, I come out halfway between these two concentric circles. I'm about right there and about right there. Notice how this thing's starting to close back down. And this point right here, I can eyeball this one, that is 6 units from the directrix and 3 from the focus. That's going to, because that's right on this perpendicular to the directrix again, that is going to be another vertex. Oh, here's your ellipse. Okay, all right. Now we're ready for the hyperbola. I'll do this in blue. And we'll make the eccentricity 2 for this. So D2 is equal to twice D1. Okay, we'll start with D1 is 1 and D2 is 2. Okay, that's going to be a vertex. That's a point right here. And I'll leave it as an exercise to the student to figure out why that's a vertex and why these are the minimum distances that are going to form a point on the hyperbola. All right, we'll go to 2, 4. All right, remember D1 is distance from the directrix, so I lay my ruler 2 units from the directrix. Count out 4 circles. 1, 2, 3, 4. There's a point. 1, 2, 3, 4. Another point. Okay, we'll go 3, 6. All right, I slide my ruler. Come out 2 more concentric circles from there because we're going out by a factor of 2 here. 2 from there, that's 6 from. Okay, and you can see that one of the branches of the hyperbola is forming here. Now, the other branch has to be on the other side of the directrix. And it just so happens that these are the dimensions. Now, here, these points on the edge of the straight edge are 3 from the directrix. Well, that point right there is at the same time 6 from the focus. So that satisfies a condition, and there's another vertex. All right, we'll go 4, 8. Now, on this side, I'm 4 away. I come out 2 more concentric circles. I got points on the hyperbola. On the other side, I'm going to go over here. This is 4 from the directrix. These points satisfy the 4, 8. Well, we can go 5, 10. And let's see, we're about here and here. We'll come back over here. 1, 2, 3, 4, 5. Here's my straight edge, parallel to the directrix. These 2 points are 5 from the directrix and 10 from the focus. If I count it all the way back over there, I'd be 10. Well, you can see it, can't you? And here, is the hyperbola. And you should build your own, sketch your own. I want everybody to do it. Okay. Well, I'm going to end this video, and I'll start another one on how you're supposed to do your homework. But I don't want to screw this up because everything worked just about the way I wanted it to for this one.